I'm starting to notice lots of posts and articles on the topic of why developers are dropping microservices as an approach. I think that this is probably wrong, but also probably a mistake if true. So are developers dropping microservices? And if so, why is that? And what can we learn from all of this? And how could we do better? That's our topic for today. Hi, I'm Dave Farley of Modern Software Engineering. Welcome to the channel. If you haven't been here before, please do hit subscribe because it helps us reach a bigger audience. And if you enjoy the content today, hit like as well. So first, is this really a thing? Microservices as an approach remains very popular, and you can see that from this Google Trends graph. As a search term at least, microservice doesn't seem to be going anywhere at all. But based on the number of articles on the subject with titles like The Death of Microservices or Why Microservices Aren't Popular Anymore, there's certainly some realization that things aren't quite as straightforward as people once thought. As I started exploring this idea online, there were a lot of links to one article that doesn't exist anymore, published by Amazon a couple of years ago, which describes how they dramatically improved performance and reliability and reduced costs by moving one of their applications from microservices to a monolith running in EC2. I think that this article may well be at the root of the flurry of posts on the death of microservices. It's referenced so often, which is kind of ironic because if you read the description of the so-called microservice approach that they describe in this post, it raises some questions. Thanks to Wayback Machine, here's an architectural diagram from that disappeared article. My first thought is that this looks nothing at all like a microservice design to me. One of the defining characteristics of a microservice is that it is based on services aligned with a bounded context. Can you see any sense of bounded contexts in this diagram? Given the aim of this system is to analyze frames and audio buffers in real time, looking for defects, I'd expect to see something about video streams identifying defects maybe in buffers and frames. So okay, some of these concepts are mentioned around the edges of the system diagram, but seemingly only as inputs to the bit that presumably is meant to do all of the work, which looks more like a generic diagram for process stuff to me. This is the core of the system, which is built from AWS step functions. Step functions are an orchestration system that manages workflow between services, often pre-canned generic services. This is not really the same thing as a microservice architecture at all, by any stretch of the imagination. So doesn't by itself make this a microservice approach. The original article says that it was this orchestration that was the bottleneck that made system perform so poorly. This isn't really surprising since they're using a generic low-code tool for processing high volumes of data. That doesn't sound like a very good strategy to me. It sounds pretty risky, despite the fact that Amazon claims that this is exactly what step functions were good at. The cynic in me does wonder if this is why the original article is no longer available on the Amazon site. They realized that this story exposed a weakness in their own design and their misuse of their own tools, rather than a weakness in microservices in general. Let me pause there and say thank you to our sponsors. We're fortunate to be sponsored by Equal Experts, Transfic, and Mailtrap. Mailtrap is an email platform that developers love for fast email delivery, high inboxing rates, and live 24/7 expert support. Check their details out in the description below. All of these companies offer products and services that are very well aligned with the topics that we discuss on the Modern Software Engineering channel every week. So if you're looking for excellence in continuous delivery and software engineering in general, do check on their links in the description below and check them out. Thank you. Let me be very clear here. I don't want to sound like a microservice apologist or a flag bearer. I also don't want to dismiss a popular, effective tool for no good reason. I think that microservices are the best solution to the problem of scaling development activities. They allow small, decoupled, autonomous teams to make progress independently of one another when they're done right. That's what they're for, really, and that's the reason that Amazon, Netflix, Spotify, and many, many others built their business on this approach. You can see what the Spotify CTO has to say about their use of microservices in this video. But microservices are often a poorer choice for small teams. And the reason for that is that there is a significant overhead of complexity in microservices that simply can't be ignored. The complexity comes in several forms. If you'd like to learn more about the traps waiting in the weeds of microservices and how to avoid them, do check out my new LeanPub training course, Mastering Microservices, for a more in-depth exploration of some of these pitfalls and the ways to avoid them. Follow the link in the description for a discount on this new course. The whole win for microservices is captured in the opening paragraph of the original definitional article. They are systems built from suites of independently deployable services. If you can't deploy your service without testing that it works together with other services first, then this isn't a microservice. This defining characteristic places a very high bar on design. You don't get independently deployable services unless your design is very good, well abstracted, very decoupled, very modular. And that's the real point. If you follow the guidance, the sometimes demanding constraints of a microservices approach, it will keep you on track to achieve the promised benefits. But if you ignore that guidance and simply think that microservices are all about small services, each in its own repository, without really worrying about the coupling between them or ideas like decentralized data management and deployment independence, you'll miss the point entirely and suffer the costs and consequences as a result. To achieve the kind of benefits that the successful use of microservices depends upon, if our designs must be more decoupled from one another, then there must also always be a trade-off cost for this decision. It isn't that microservices are a mistake, but rather that to gain the benefits, you must also be cognizant of their costs. Decoupling at the boundaries between microservices means that translation at those boundaries. We must insulate one microservice from changes in another, and so must preserve a difference, or at minimum a potential difference, between the internal representation of the service and its external contract with other services. This always means doing more work at these boundaries, and so whatever form that translation takes, it will always be a little slower than no translation. Add on top of that the cost of a remote call across a network, and this cost is dramatically higher than any local in-process call. Add in addition an allowance for all the ways in which remote calls can go wrong, and speed reduces and complexity explodes. As I keep saying, none of this means that microservices are a bad idea. It just means that they aren't always a good idea. And that even when they are a good idea, you need to approach them with a bit more caution than simply dividing the work up into tiny pieces, each stored in its own repository, and then having a big integration phase to try and make all of these pieces work together later, and a big test phase to verify that they do. This greater caution is about two things, really. A degree of sophistication in development approach and a degree of sophistication in terms of design. The developmental scalability of microservices is dependent on our ability to work autonomously. We need to be able to easily and safely change them without depending on other people outside our team being forced to coordinate what they're doing with us, or us being forced to coordinate what we do with them. So we need our changes to be organizationally and technically decoupled and isolated. We need to achieve this by careful compartmentalization of the problem, dividing them into services, but also abstracting the conversations between those services so that we can change the services at either end of the conversation without changing the nature of the conversation. This means that we need to be able to make such changes confident in our ability to do so without compromising the conversations. Those interfaces between the services, then, are important. This means good design as well as good testing and good feedback. This is a pretty complex design problem, but it is fundamental to making the microservice approach work well. I would argue that autonomous teams with full-blown continuous delivery, trunk-based development, TDD, and continuous integration are really table stakes for microservices approach. If you don't do these things, then I'd say you're doing it wrong. In most cases, I'd add that you also need contract testing in some shape or form, and strongly recommend a ports and adapters approach to design to defend these crucial interface points between services. You can't sensibly be sure that your changes are safe and won't leak breakages to each other without all of these things. These things are what I mean by sophistication in development approach, and this is all complex enough, but we aren't finished yet. By definition, microservices are components in a distributed system, and distributed systems are complex in lots of interesting ways. Because they are distributed and so successfully compartmentalize the system, a well-designed microservices system can be easy to scale up in terms of computation and performance too. We can have more opportunities to scale services independently of one another because the boundaries are obvious. But again, this depends on thinking carefully about how we divide up the problem and how we avoid sharing data between services. How we avoid all the pitfalls of distributed system, things like circular chains in communications, distributed transactions, race conditions. And we need to think of ways to deal with the fact that now we're exposed to deadlocks, resource starvation, and deal with ideas that are very complicated like eventual consistency, bulkheading, data sharding, back pressure, and other arcane complexities of concurrent systems. How do we trace paths of execution and understand or debug failures? Given all of this, it's not really surprising that teams that have not previously been exposed to these sorts of distributed system challenges find microservices a lot more complex than they thought they'd be. So perhaps it's also not surprising that many people who have now experienced this complexity, when they expected a much simpler approach to building these complex distributed systems, have felt somewhat disillusioned. But I would certainly recommend pausing before throwing the idea away completely. This is really about what are you comparing it to? The truth is that large distributed systems are always extremely complex things. They may be easy to develop if we get things right, but they are never simple. I believe that a distributed service model is probably the best way to organize live systems generally. It provides a valuable organizing strategy that gives us some loose guidelines on how best to arrange things, to limit the impacts of all of this complexity that we've talked about inherent in distributed systems. These loose guidelines are called out in the original definition of microservices by James Lewis and Martin Fowler. And if you're working or intend to work on systems like these, I recommend that you read and carefully think about what they say in that description. There are ideas here that are important to take seriously if you're going to succeed. Microservices is a much more than only about small services. It's about how they are divided up and how they communicate. Here are a few ideas from that original article and my thoughts on them to help you to follow the advice in those loose guidelines that's all too often ignored. They're based on componentization via services. If nearly every change requires the coordination of work in different groups of people and changes in multiple services, you have a problem. Because now microservices will make that kind of work more difficult, not less. One guideline that helps with this is that microservices are organized around business capabilities. This naturally helps us to divide the problem into less coupled, more independent pieces, separated by clearly defined abstractions of the conversations between them. This isn't easy to do well, and one way to help us to better achieve this is to approach microservice development as products, not projects. This matters because what this is really calling out is the vital importance of an incremental, evolutionary approach to design and development. You aren't going to get all of this right first time, so assume that you'll need to adapt and change things as you learn more. Use the stuff that I talk about to make your code easy to change. That is one of the reasons why micro is there in the name, by the way. A good microservice system is composed of many small, simple pieces. The key to this idea is perhaps rather subtle, in that the communication between the pieces matters more than the pieces themselves. This is hinted at, but to my mind, perhaps not clearly enough called out by the idea of smart endpoints and dumb pipes. I would add to this that the real design of a microservice system comes in the design of the conversations between the services rather than the implementation detail of the services themselves. The implementations at the smart endpoints are somewhat more tactical. In part, this is because of the need to achieve decentralized governance and decentralized data management. The benefit and major advantage of microservices is that it is a wholly decentralized approach. This is true both in technical terms, but even more importantly, if you aim to get to the real benefits of a microservices approach in organizational terms. We decentralize decision-making, making every autonomous team responsible for its own small part of the system as a whole. This comes at a cost of a loss of standardization because these teams are working more independently than before, but at a huge advantage of enabling them to make progress in parallel without being constrained by what other people are doing. And this works for sometimes very large groups of people indeed. Microservices is the most scalable way to build software, but it's probably a mistake for small teams. And whatever the size of the team, it comes with some significant overheads and demands a level of sophistication and thoughtfulness. So don't dismiss it, but also don't treat it lightly as some kind of silver bullet. Thank you very much for watching. And if you've watched this far, thank you for supporting our channel. And if you'd like to support us further, why not consider joining our Patreon community? We have a very active Discord channel where you can discuss ideas in depth about software engineering and a wide range of other topics that we talk about here on the channel. There's links to how to join that in the description below. And to our existing Patreon members, as ever, thank you very much indeed for your support. It's very much appreciated. Bye-bye.